Overview of TCP/IP or Transmission Control Protocol Internet Protocol. In this video, we will explore the structure and components of TCP/IP and how it enables the transfer of data over networks. Additionally, we will also discuss the Internet Protocol, IP address, and its structure, which is an essential component of the TCP/IP protocol suite. TCP/IP is the system of protocols that governs the transfer of data over networks. It includes a set of rules for manipulating packets of information to ensure correct delivery. The first version of TCP/IP was created in 1973 by Vinton Gray Cerf and Robert Elliott Kahn. It has gone through multiple stages of refinement until TCP/IP version 6. An Internet Protocol address is a numerical identifier assigned to each device that uses the Internet. It consists of 4 sets of numbers known as octets, which are separated by periods. For example, 192.168.1.2 is an IP address for one of the computers on my home network. Each octet is a value between 0 and 255, which gives the maximum of 256 unique possible combinations for each set of 4 numbers. This means more than 68 billion IP addresses are currently available for assignment to worldwide devices, and IP addresses are assigned by the Internet Assigned Number Authority, IANA. Data transmission in TCP/IP. Data is transmitted digitally as a string of ones and zeros, and it can be sent in packets, individual data bundles separated by a certain number of bytes or characters. Packets are created when a device, such as a computer or a printer, sends a file across a network. TCP/IP uses the term segment to refer to a packet of data sent from a device on one level of a TCP/IP-enabled computer system. It is only a segment until it reaches the next layer in the system, at which point it becomes part of something called the Internet Protocol, IP. While TCP/IP is often used interchangeably, it's important to understand that they are distinct layers in the network communication stack. Here's how they work together. The IP layer is responsible for breaking down data into packets, adding header information with the source and destination IP addresses, routing packets independently across the network based on their IP addresses. The TCP layer is responsible for ensuring reliable data transmission by adding sequence numbers and checksums to packets, tracking which packets were successfully received and requesting retransmission of lost packets, ordering packets at the receiving end to ensure the data is reassembled correctly. The structure of an IP data packet can be visualized as a layered model, with each layer holding specific information crucial for sending and receiving data successfully. Here's a breakdown. Header, 20 bytes. Version identifies the IP version, currently mostly IPv4 and IPv6. IHL, Internet Header Length, tells how many 32-bit words are in the header, usually 5 for IPv4. Type of service provides information about priority, reliability, and throughput for the packet. Total length shows the entire packet size in bytes. Identification, used to identify fragmented packets belonging to the same message. Flags indicate control functions like fragmentation or do not fragment time to live, TTL. Prevents packets from endlessly looping if routing goes wrong. Protocol specifies the upper layer protocol, for example TCP/UDP, used to carry the data. Header checksum ensures data integrity within the header source IP address, identifies the device sending the packet destination IP address, identifies the device receiving the packet data payload. Variable length contains the actual data being sent, which could be anything from website content to file transfers. Maximum size depends on the IP version. Around 65,500 bytes for IPv4 and 4.29 billion bytes for IPv6. Optional options, variable length, not always present. These add extra information for specific needs, like security or routing. Maximum size and available options differ depending on the IP version. Each field within the header has its own set of values and subfields with specific functions. Data is transmitted digitally as a string of ones and zeros, and it can be sent in packets, individual data bundles separated by a certain number of bytes or characters. Packets are created when a device, such as a computer or a printer, sends a file across a network. TCP/IP uses the term segment to refer to a packet of data sent from a device on one level of a TCP/IP-enabled computer system. It is only a segment until it reaches the next layer in the system, at which point it becomes part of something called the Internet Protocol, IP. For example, imagine you are sending a letter to your friend across town. Here's how it works with TCP/IP, like the Internet's postal service. First, you write the letter on a paper and post it on a letterbox. Your letter gets divided into smaller sections, like paragraphs called packets. Each packet gets its own envelope with your friend's address labeled on it. Each packet knows where to go thanks to its address, a special code called an IP address. It's like having a zip code, but for the internet. These packets then hop on trucks, routers, that take them closer to your friend's city, one hop at a time. TCP, another part of the system, plays the role of your trusty assistant. It keeps track of which packets reach the destination and asks for any that got lost to be sent again. Once all the packets arrive at your friend's town, they get reassembled in the right order, like building a puzzle. Finally, your friend can read the whole letter. TCP/IP and different types of digital information. While TCP/IP is primarily used for sending text, it can be applied to any digital information, including pictures, videos, or music files. Each type of file is broken down into its unique format before being transmitted to be appropriately reconstructed when it reaches its destination. In conclusion, TCP/IP is the foundational protocol suite that enables data transfer over networks, including the Internet. The protocol has undergone several stages of refinement, starting with its first version in 1973 to the current version 6. TCP/IP uses packets or data bundles that are created when devices send files across a network. Each packet includes information about its source and destination, as well as port numbers that define how it should be handled once it reaches its destination. The Internet Protocol, IP, further divides each segment into smaller packets, ensuring successful transmission and delivery. Understanding TCP/IP is essential for anyone who uses the Internet, as it is the underlying technology that makes these communications possible.